I'm Patrick Lewis, the Director of the Technology Transition Division at Hepburn & Sons, where we focus on de-risking and maturing technologies for transition readiness to support our warfighters with enhanced capabilities. In this presentation, I will be discussing a small business technology transfer project that we are performing with Florida State University on ground fault detection on low-voltage alternating current distribution systems. Hepburn & Sons provides expert advisory and engineering services as trusted advisors to the American maritime industry in addition to technology transition. The Technology Transition Division specializes in developing and transitioning advanced technologies to revolutionize our war-fighting capabilities. There are several ongoing technology projects such as MVDC partial discharge and space charge testing, MVDC insulated bus pipe, and compact and hatchable transformer rectifier. The company was founded in 2010 and is based out of Manassas, Virginia. The company is comprised of 3 divisions that align with our main objective areas: advisory services, engineering support services, and technology transition. The Advisory Services Division's 2 primary functions are strategic analysis and expert witness. Engineering Support Services provides expertise in naval architecture, naval engineering, ship integration and safety, test planning, execution, and overall program coordination. The Technology Transition Division de-risks and matures strategic technologies for transition readiness in defense applications. Hepburn & Sons is proud to partner with industry leaders and distinguished universities throughout the country in support of our many government clients. The vision is to lower integration risk and mature technology for mission-critical DoD needs. We bridge innovative research, advanced technology development, and national capability needs. The division has specific capabilities in innovation incubation, system of system engineering, technology transition campaigns, technology maturation and demonstration, and technology dual-use commercialization. The U.S. Navy seeks a ground fault detection system to quickly detect and localize all ground faults on 440 voltage, alternating current 3-phase shipboard distribution systems that are either ungrounded or high-resistance grounded. The system shall be capable of identifying the correct feeder cable that has ground faulted at least 90% of the time. The system shall also be capable of correctly identifying the location of the ground fault on the faulted cable within 3 meters at least 75% of the time. The current U.S. Navy shipboard electrical distribution systems are capable of maintaining operations when one of the 3-phase endures a line-to-ground fault. If there is a second ground fault on another phase, a line-to-line fault will occur, resulting in circuit breakers tripping and loss of power to loads. The current method for isolating a ground fault involves opening breakers until the location is narrowed down. This significantly impacts a ship's operational readiness and warfighting capability. Hepburn & Sons partnered with Florida State University Center for Advanced Power Systems in developing a ground fault detection and localization system. The design applies noise pattern analysis using a one-dimensional convolutional neural network to identify and locate the fault. The prototype design will be capable of identifying the correct feeder cable with at least 90% accuracy and locating a fault within 3 meters with 75% accuracy. The design is planned to be implemented into a rugged, portable Linux-based PC with high-speed, high-precision voltage and current probes with data acquisition cards. The prototype design algorithm has been trained on data acquired from the Scripps Oceanography's Sally Ride research vessel. The project is currently in the first option year of Phase 2 and funded until September 2024. The team is developing the prototype and is expecting to be at Technology Readiness Level 3 by September 2024. The Phase 2, Option 2 period will focus on the development of the technology, validation, and demonstration tests. with Phase 3 focused on commercialization. The current design will be compatible with LVAC power distribution systems. The design uses noise pattern analysis, driven by the one-dimensional convolutional neural network, to identify and localize the faults. The data is collected with high-speed, high-precision voltage and current probes, and is fed into the algorithm, which can be trained to specific systems. The system provides quick detection of a single ground fault before a double-lined ground fault can occur, resulting in circuit breakers trips and loss of loads. The design eliminates the need for manual disconnect hunting of fault localization by time-consuming trial and error. Hepburn and Sons is seeking a Phase 3 transition and production partner. Before the technology can be transitioned to the fleet, additional full-scale system development, testing, and qualification will be required outside the scope of the current project. Potential Navy applications include Shipboard 3, Phase LVAC, ungrounded or high-resistance grounded power systems. Potential commercial applications include the medical industry, life-critical medical facility systems, process control industries, and high-resistance ground power systems. The strategy of Hepburn and Sons LLC and Florida State University is to work with the end production in mind. Qualification of technology for U.S. Navy requires Program Office and NAVSEA 05 involvement. The technology warrant holder community provides the mechanism for the technology to be included on the qualified parts list for shipyard use. The Program Office creates the pull for the technology and design guidance for shipboard installation. The team is still searching for a Phase 3 commercialization and production partner. Hepburn and Sons LLC is located in Old Town, Manassas, Virginia, less than an hour west of D.C. If you have questions about this technology or are interested in other technologies that we are de-risking for the warfighter, please use the contact info shown in this slide deck to get in touch.